When working with neural networks, our goal is usually to solve problems of classification or regression, like is the picture a cat or a dog, or what will be the lifetime of a specific product. For this to succeed, we first train our neural network on some training data. Let's say that's that part here. And then after the network has trained, we can look at its accuracy. So here is epochs, and here is accuracy. And maybe it looks something like this. And maybe we're happy with that value here. And so the impression is we trained a good model. But how do we know if our model will perform well on data it has not seen yet? So that's that part here. The answer is we can't. A network with sufficiently many parameters may even have adapted to memorizing the whole training data. And so the accuracy may look like this. For why it may even go down, you can check out the next videos. And so to be aware of how our model will perform on unseen data, we need a validation dataset. This dataset is a subset of our whole dataset, so that can be that part here. And we use this validation dataset to check if our model can only predict or classify what it has seen before, or if it can generalize well to unseen data, which is what we want. Now you may think that with these two datasets we are good to go and can train our network and also validate that it generalizes sufficiently well. But of course, this empty part here suggests otherwise. And now imagine the following. In the first attempt, your model sucked. It performed badly on the training and also on the validation dataset. So you add another layer, maybe change the learning rate, or tune some other hyperparameters. After a lot of messing around, you finally get great performance not only on the training data, but also on the validation dataset. Feeling very content, you also try out your model on a third subset of the original dataset. Much to your surprise, the model does not perform well on this third subset of the data. So maybe the accuracy looks like this. What happened? Well, although the network has not seen this subset, we'll call it the test data, just like it has not seen the validation dataset, the difference is that this new test data has also not been seen by us. So by messing around with all kind of hyperparameters and or different network architectures, what we have done is optimize the network for our validation data. And so in a sense, we were the guidance dog to our network that now helplessly wanders around in the presence of the really new data. And so that is why we split our original dataset in 3 parts. One for training the model, one for tuning the model, and one to test the performance of the final model configuration.